Okay, we can get started. Let's try this one to get started. So these are some problems that were submitted. So I'll give you a minute to try, or a little more than a minute. Make it a little bit bigger. Okay, for this one, I'm going to show you two different ways. There is a little bit of a shortcut, but I want to go over the Desmos way to make sure that we know how to use a table in Desmos. So for any function where they want you to either linear, quadratic, or exponential, and you're given either a table or a series of points, what you could do is go to Desmos. And for linear, we only need 2 points. So if I go to Desmos, what you're going to do is add a table. And then I'm going to put in 1 comma 32. And then, so again, you only need 2 points. You don't have to waste your time putting in the full table. And then 228. And then you just hit this add regression. And you can see right here, it just gives you the equation of the line. So they tell us that the equation is y equals negative 4x plus 36. So then I can jump back. And if it was negative 4x plus 36, they just want the value of b, which has to be 36. So that's a nice, easy way to use Desmos. Before I show you the shortcut, does anybody have questions on that?
No.
Okay. So now for the even bigger shortcut. So it's because the long way would be to find the equation by hand, by finding the slope and doing all that. Um, okay, yeah. So, but there's an even bigger shortcut. So that's super useful to be able to use Desmos. Now, another thing is to understand that B is the y-intercept. And the y-intercept in general is just when the x is equal to 0. Well, if you look at the pattern in the table, if I want to know when x is 0, then I'm just working backwards 1. And notice it's going down by 4 every time. So if I go backwards 1, it's going up by 4, and I just get 36. So, there's a way to just get it pretty much immediately. But it's not always like that. And if you don't see that, then the table is a quicker way than being able to, having to do it all by hand. So you should not be writing any equations of lines when you're given a couple points. The table, you can just always use the table. Okay, let's move on to the next problem. This is a circle problem, so let's try that. All right, so this one is pretty straightforward as long as two things. You know the equation of a circle, which this is not given. They give you the area of a circle and the circumference, but they do not give you this standard form of a circle. So you really need to know this. And the H and the K represent the center. So 19 is H and 18 is K. So we should have X minus 19 squared and then Y minus 18 squared. Okay, so that tells me that doesn't honestly really help because every answer has that. And then you've got to do this part appropriately. If the radius is 9K, that's this R. So what's really happening is you have 9K quantity squared, and that's 81K squared. So the answer is B. But you just got to be, again, you got to be really careful with, not choosing D. That's a mistake I see a lot. You got to make sure you square the 9 and the K. Okay. Any questions? All right, then let's keep going. Let's take a look at 3. I can make this one a little bit bigger. This one's pretty tricky. So They like to ask problems like this. So don't worry about this like unit. What we know is that the just pretend it's like pounds or something. So the total mass of the M and the K is always this, no matter how many M and K there are. With these types of problems, what you typically want to do is you want to zoom in on either one of the intercepts, depending on what they ask us. So what this intercept represents is, I'm going to just assume it's 160, is this is the point 160 comma 0, which means I have 160 of the M type stars and none of the K type stars. That's what I want. Because if I have because if the total weight or mass is always this number, and I want to know the mass of each M type star, then what I want to do is I want to pick the point on the graph that doesn't have any K type stars because I don't need to know anything about that. So basically, if 160 of these stars is this big number, then all I have to do is divide to find out what one of them is. So all I'm going to do in the calculator is this number divided by 160. And when I do that, I get like 799. But that answer's not there, but it's just, it says which is the closest, because this wasn't exactly 160. It was a number probably a little less than 160, but I can just assume that it's A, because that's obviously the closest. And if the problem had asked for the mass of the K type stars, then I would have used this point over here. So only the intercepts are useful in a problem like this. Okay. Any questions on that? Okay. Then let's, good. All right. Now we got a trig problem. So let's take a look at number 4. Okay. So this is an example where they give us information that doesn't really affect the problem. So just like when you see things like this, just ignore them at first, and then maybe we'd have to go back to them. But in this one, it's going to end up not mattering. We want the length of QS. I'm just going to call that X. And then if I have to use a trig function, but I also need an angle to use as like a reference point. And just the answers tell me that I should be using angle Q. Because in general, I could use angle S if I felt like it. So then when I look from angle Q's perspective, the 18 is the opposite side and the X is the hypotenuse. So if we think of SOHCAHTOA, this is the opposite and the hypotenuse, so I'm using sine. So I can get rid of A and C. And then the way I do it is the sine of the angle. So the sine of Q is equal to the opposite over the hypotenuse. And if my goal is to get X by itself, then I can multiply each side by X. And then I can divide each side by sine Q. So X is going to be 18 over sine Q, which is answer choice D. All right. So the answer, the key here is to look to peek at your answers, because we easily could have used S to solve this problem, but the answers didn't have S. So look at the answers to kind of help you decide which angle you should be using. Okay. Any questions? All right. Okay. All right. Let's take a look at number 5. So for this one, again, a lot of these word problems is kind of about ignoring some of it. So just ignore like this until we get here. So the predicted power is 433 at a speed of 3,331 RPM. So if I think of that as a coordinate pair, I do go back here, and it says, um, hold on a second. Okay. So it says that the F is the predicted power, which is like the Y. Um, and then for engine speeds, like the RPM, that's the X. So this tells me that the 3331 is the X value and the 433 is the Y. Now, I don't need this, but I do want to go over this. This right here would then tell me that I have an X value of 4,500 and a Y value of 600. Um, so I could use these 2 points and use like a Desmos table. But the issue with that is we have to know that the Desmos table is going to give us the answer in slope intercept form. But if you see that way this is given, this is not given in slope intercept form. So I wouldn't do that. All right. What I would do is just pick one of the points. I'm going to pick this one, and you'll see why this one ends up being easier. And I'm just going to plug it in for x and f of x and solve for a. So again, f of x is the 433, and x is the 3,331. And then I'm just going to solve for a. So if I subtract the 433, I get 0. And then if I multiply each side by 7 to get rid of this 1/7, I still get 0. And then hopefully we can see that a has to equal 3,331 in order for us to get 0. So in this one, even though they gave us 2 points, I wouldn't have used the table because the equation that we were looking for was not in slope intercept form. So this one, the way I did it is just plug in the x and f of x or x and y and solve for a.
I don't have any questions.
Awesome. Okay. Let me see if I can make this bigger. That might have just made it harder. You know what I want to do on this one? Okay. So we're looking for the graph that matches this. And I'm just going to write it a little bigger. So we have x plus y equals 53 and 11x plus 18y equals 730.
I got B.
That is correct. Yeah. So yeah, did you use Desmos on that one?
Yeah.
Okay. So yeah, that is basically what I was going to say is one way to do it is to just use Desmos, which doesn't take very long. Also, just to show you another way, because again, this concept could be useful maybe in another problem. When these are in what's called standard form, so we're typically used to graphing from slope intercept form, but if you're graphing in standard form, then what's easy to find is instead of the slope is just the x and y intercepts. And basically the x-intercept is just this number divided by whatever the coefficient of x is, because the way you get an x-intercept is you plug in 0 for y. And then the way you would find a y-intercept is you would plug in 0 for x, so it would be this number divided by whatever the coefficient of y is. So the only way this could be faster, so instead of plugging it into Desmos, if you see that automatically the x and y intercepts have to be 53, that gets rid of a and d. And then when you find the x and y intercepts of this one, it's just 730 divided by 11 is the x-intercept of this one. And it's like 66. And you can see that this one, okay, so that's the same. Oh, no, we already got rid of that one. My bad. So then this one is just wrong because the x-intercept is supposed to be 66. So I don't know that that's any faster than Desmos, but it's just another way to look at it. And there could be another problem where if something's in standard form, just like finding the intercepts could be quicker than doing it another way. So I just wanted to go over that. But yeah, the answer is definitely B. But good. All right. So take a look at number 7. All right, so this is similar to one earlier. So I took the problems that were submitted basically, and I just kind of focused on these linear functions and tables. So this is another one that we could use Desmos, but there is the shortcut of if we want the y-intercept, then that's just when x is 0. So that's just working backwards this way. Notice the pattern is the same, and this pattern is going down, like this way is going down by 3. So that would just mean that this is 3. So the answer is just D. Or just use the Desmos table, and you should see that the equation um, has a 3 in the position of B.
Makes sense. Your shortcut made more sense.
Okay, good. Okay, so I'll try this one. This one does not ask for the y-intercept. There is a way to use a shortcut, but I also want to go over the Desmos way. So try that.
D.
Yes, that is correct. Did you use Desmos?
Yeah.
Okay. So I do want to just go over something real quick in Desmos, but let me just write down the points. 119, 737. So I'm just going to use the positive numbers. I just want to go over one small thing that you may or may not have done. But so if we look at the problem kind of fresh, so we put in the table, and then we have 119, and then 737. And then we do this. All right. So we have to find when x is 4. So there's two pretty good ways to do that. One is you could just export the equation, and then you could just change this to k of x, like the problem assigned it. You could use f of x too if you wanted. And then you could do k of 4, and that gives you 28. Or you could just plug in 4. I realize that's easy in this one, but I'm trying to look at generally if the numbers were bigger. Um, and then even yet another way is instead of doing that, you could just plot the equation x equals 4 and then just see when it intersects. You can see the downside of this one is that I have to zoom out. So that you see you get 28. All right. So just to recap, the way I look at it is this one, the way I would have probably done it is just plug in 4 in my head because 3 times 4 plus 16 is easy. But
Yeah,
if this,
that's what I did.
yeah, exactly, good. But if this equation has got, fractions and negatives in it, and you don't want to do that in your head, then either exporting it and changing it. So again, I could do like f of x if I felt like it. And then you could use it to evaluate kind of anything you wanted. Or I would graph it if I didn't think I had to like zoom out. So there's just a couple different ways to do that. And then this one does even kind of have a shortcut, is that if you notice that they're asking us for 4, which 4, whoops, 4 is directly between 1 and 7. So since it's linear, the answer is just going to be directly between 19 and 37. And the way that you find the number halfway between something is the average. So you could just do 19 plus 37 divided by 2 and also get 28. So just things to look for. I definitely think the Desmos way is like super fast. So, but it's good to kind of see all these different options. So any questions about any of that?
No, the Desmos made the most sense, I guess.
Okay, cool. Okay, try this one. This one's interesting. Okay, so this one is a little bit harder because we don't know A or B. All right, but if A plus B must always be the same value, or they wouldn't ask us that and it wouldn't have an answer. So I would do this. The what I would do to start, whatever method I choose, I would do the same thing to start, is I would just make up my own value for A. I'm going to choose 8. I'll explain, I guess, kind of why I did that in a second. But there's a bunch of values I could have started with. And then I am not going to choose the Desmos way, because now all I need to do is find B. And again, it's linear, so there's a pattern. So by me choosing 8, then this is going up by 4, which would mean this is 16. And 8 plus 16 would be 24. And what you can see is if I picked different values, like let's say I picked 6, then it would be going up by 6, then it would be 18, but 6 plus 18 is still 24. So it doesn't matter what values A and B are. They could be different values themselves, but they will always add up to 24. And that one, I would just use the pattern as opposed to trying to use Desmos. But to get started, the way I would probably do it is to just choose a value of A, then figure out what B would be based off of that, and then you got your answer.
Okay.
Good. Yeah. So that's why we like all the problems we've done so far, like Desmos was fine, but we don't want to like overly rely on that, because then if you choose 8, you plug these in, you find the equation, then you got to plug in 2. Seems to be like extra work than just like using the pattern. Okay. All right. So now we get into some other problems where we may or may not be able to use a table, but it's not like the table's not given. We're given 2 points. So this one's a little bit of a harder problem, but I'll give you a little bit to try that. Okay. There's a couple different ways to do this. The first thing we're going to have to do is come up with the equation of the line. I did not use Desmos, but you could. So even though they didn't give us a table, they did give us 2 points. So if you use a table with these 2 points, you could just find the equation of the line. But I didn't, because I can see what the slope is pretty easily. I'm going down 3 over 5. So that means my equation is negative 3 over 5x. And then the y-intercept is just given here to be 3. So I found the equation just pretty quickly from the given information. But if you don't see that, that's fine. You could use a Desmos table to use these 2 points to give you the equation. Then I know that this point is A comma B, but B is 2A. So that point really is A comma 2A. Then what I did, I just plugged that in. So Y is 2A and X is A. And now we're just solving for A. So if you wanted to use Desmos for that, you could, but I just multiplied everything by 5. So 10A is negative 3A plus 15. And finally, add the 3A over and you get 13A equals 15. You'll probably stop there, because if we divide each side by 13, I would get 15 over 13. So that one I chose to do all by hand, but you definitely may be able to find ways to use Desmos to do it more quickly for yourself. But any questions on that?
Nope.
All right, cool. All right, so I got 2 more. Take a look at this one. Okay, this one I am going to just use Desmos. We could probably do it pretty quickly by hand, but I want to go over it because it might not be as obvious as to how we can use Desmos. So what I would do is we've got this point 3, 2, but we also have the point 0, 6. So that 6 represents the y-intercept. So knowing that, one way you could do this is you could just use a Desmos table. I just want to kind of show that you don't always need a table. You really just need 2 points. So we had the y-intercept, which was 0, 6, and then the point 3, 2. And then you just go here, and then you can see the slope. Okay, so now here might be the downside of it, of using Desmos, is you get negative 1.3 repeating. You then have to know which answer that is. So that's clearly the slope. And then of our answers, negative 1.3 repeating is negative 4/3. So the downside of the Desmos table is if you get some sort of decimal that doesn't terminate, um, it's not going to turn it into a fraction for you, not appropriately. You've got to kind of know that. So then, if that is the problem, then I probably would have just done like the normal slope formula. So 6 minus 2 over 0 minus 3. And you can more easily get for negative 4/3. So just want to like show you all the different ways and just the kind of downside of sometimes using Desmos, but you can use it even if a table's not given, as long as somehow the problem gives you 2 points and it's a line, you can use Desmos, but as we saw, it may or may not be faster.
Okay.
All right, let's do one more here. Try that one. Okay, so again, we have a couple different ways. You could just use a Desmos table and plug in two of the values. You just have to realize that they're switching the letters on you. But another way we could do it is, let's say we're doing y equals mx plus b. And the m is the slope. Well, if I start here, notice every time I go up by 1, I'm going up by 3. So that just tells me the slope is 3. And then the y-intercept is just when I plug in 0. So since both of these are like right there for me, it might be easier to do that than even take the time to put it into Desmos. And then hopefully we see that all they're doing is changing, like they're calling now XA and YB. So the answer is just D, because it's 3x plus 3 is 3a plus 3. So they do that a lot, just like switch letters to kind of like mess with you. But whether you use Desmos or you do it by hand, you're going to have your equation with x's and y's, and you just got to give the equation that's the same, just with a's and b's.
Okay.
Okay, well, that was all the questions I had for tonight. So if you don't have any other questions about anything, then we can be done. So was there any other questions that you had?
Nope.
Okay. Well, thanks for coming, and I will see you same time next week, and I'll email everything out later in the week.
Okay. See you next week.
All right, bye.